Introducing Portraits and Ideas. I'm Earl Gal presenting interviews to inspire and perhaps unveil something new in the realm of ideas. So, your name and your profession?
My name is Marla Broadfoot, and I am a freelance science writer and editor.
Is that for any particular publication or?
No, I'm pretty much a free agent, but I am a corresponding editor at American Scientists, and then I write for Scientific American, and I've written for Nature News and Discover.
What? Oh, okay. That's what I was getting ready to ask about the publications that you have published. So if anybody does a search on those publications, they can find your
Yes.
articles.
Yes.
So what are some
and
of
I
the
also have a website. So,
okay. So what is the website?
it's if you look up Marla Vosick Broadfoot, then you would find it. Yeah.
And spell the last name?
Broadfoot, like a Bigfoot.
Okay.
Yeah.
Okay. All right. So what advice would you give to youth who might want to pursue a science career based on your experience?
One of the things I did when I was younger was I tried to shadow people who were doing science. I think that actually getting experience beyond the textbook is really helpful because it's all laid out beautifully in a textbook and it seems black and white, but it's a lot more complicated than that, which can be really intriguing and amazing or could be really frustrating. And it's better to know that early rather than later. And so I tried through my school to find opportunities to have a mentor. I think I went to a pathology lab where I could see autopsies. I went and met with a medical lawyer because I was interested in maybe bridging those two disciplines. I did a summer research fellowship where I worked in a lab. And those are all kind of ways that I think it's really helpful. Plus, if you want to go to college and major in that, any of those opportunities, if you put it on your college application, it helps.
So any other advice for someone in terms of just the sense of satisfaction, curiosity?
I think it's a very challenging field, but I think that if you are a curious person, then I think that it would be a very rewarding field. I actually think that everybody should look at the world with a scientific mindset. So even if you were to go get a degree in engineering, let's say, and you didn't use that degree, I think that degree would, actually be really helpful for you in anything that you wanted to do in life, even if you weren't necessarily working at an engineering firm. Because I think that just asking questions, that's what scientists do. We ask questions, we figure out a way to answer them. And that's what a politician can do when they're trying to decide what is the best policy. That is what a teacher can do in figuring out how to teach your students. I mean, every single possible discipline could use science.
So it becomes a way of thinking.
It's a way of thinking,
Yeah,
and I think that that's actually not the way that it's always taught. Sometimes it's taught as an accumulation of facts, which is a shame because it's really a process, and I think there's a lot of joy with it. There's also a lot of frustration that doesn't get taught, and so it seems like, oh, Einstein had this theory, and then he tested it, and then this is what we learned from it. But there's all these failures, and it's perseverance. So I think that maybe playing a sport and losing a few games, but then persevering and winning a game in the end is really also another way that it's not as cut and dry as you think it would be. And I think that perseverance and curiosity, and then any experience you can gain are kind of the ways to succeed in science.
In other words, you learn how to deal with challenges, which
Yes.
is also something that's a carryover to everything in life,
Yes,
so to speak.
definitely.
Right. And you don't get intimidated by challenges in a sense.
Right, you have to realize it's part of the process.
Yeah.
And, I mean, it's like an actor going
Right.
for auditions. I mean, they
Sure.
don't get their part the first time.
Sure.
And same thing with science. I mean, 9 times out of 10, the experiment doesn't go the way you thought,
Exactly.
but sometimes that's how the biggest discoveries are made.
Right.
You know.
Right. So, how did you reach the position you're in today as a freelance writer? Sort of tell me about your milestones in your education and in your jobs and your experience in science.
So ever since I was a little girl, I knew I wanted to be a research scientist, and that was what I wanted to do. But on the side, I also was really interested in writing, so I kind of did both for a long time. I felt like I had to choose. I felt like you either had to be a writer or you had to be a scientist. And so I went through school, went to college at UNC, got an undergraduate degree in biochemistry, got my PhD in genetics, and all the while remained interested in writing as well.
All at UNC?
At UNC, yeah.
In Chapel Hill?
In Chapel Hill, yes.
Yeah, right, okay.
Yeah, and I think that I realized that that my personality perhaps was not best suited for life and research. And what I mean by that is to make great discoveries, you have to be able to hone in on one thing and focus on that thing, and that's how these amazing discoveries are made. And I just wanted to learn about it all. And so I think that as a writer, I get to write about just crazy things like prairie voles, and then I write about chemotherapy, and then I write about mutant fungus. And that's not the kind of thing you would do in a research career necessarily, but I get to do that as a writer. So I actually, after I got my PhD, I did a postdoctoral fellowship, which is kind of standard for people who get their PhDs.
Sure.
And then after that, I finally made the leap to writing, because at that point it was pretty clear that I'd rather do that. And so I got a job at Duke in North Carolina, working for a year, writing about genetics and genomics and neuroscience, and did that for a year, and then I became a freelancer. And now I write for all kinds of people.
Right.
Yeah.
So, were there any inspirational scientists or writers that inspired you to go into this direction? What were your
as a child, I always loved Marie Curie. I mean,
Okay.
I loved her very much.
Sure.
I used to go around with a tape recorder and act like I was interviewing Marie Curie. So I would obviously pick her, I guess. And writing, I don't know. I mean, actually, one of my current mentors is Mary Roach. She's written a bunch of popular science books, and I got to meet her recently at a conference and have coffee with her, and it was like the highlight of my career or life, that I got to meet Mary Roach and talk to her. So yeah, I would say that she's good because she explains things in a way, it's funny and it's interesting and it's about the research and the scientists, and it's not just all, just an academic article. It's accessible.
Yeah, I would say that, the first thing you mentioned was like mentor. So that would be an example of finding a mentor.
Right.
And that's really a very powerful tool for any student.
Yes.
to search out for mentors. Do you have any further amplification of that idea?
No, and I think that, I think that sometimes you need different kinds of mentors for different things. I mean, you could have, even having a peer group is similar too, because sometimes you just need support. So it could be a mentor that's at your same stage, but they've done something you haven't done, and they can give you advice.
Sure.
And I think that, especially for women or people of color, having someone that they can see themselves being or becoming. For me, that was one of the issues when I was a scientist. I was trying to find a woman scientist who had children, because I knew I wanted to have children.
Sure.
And there's plenty of writers who had children and managed. So I think that it's helpful to find both a support group of your peers, which I think is what I rely on most of all right now.
Mm-hmm.
And then anybody you can, whenever you write for anybody or work for anybody in a lab, having someone that you can go to for advice is really helpful.
So, yeah, speaking of that question about gender, it's clear that America and the world are losing out on a lot of talent because of women perhaps not going into science for a variety of reasons as much as they could.
Yes.
What is your take on that issue?
So I actually wrote a book about it for the Burroughs Wellcome Fund on women in science.
Okay.
It's called A Place at the Bench, and you can find it on my website.
Okay.
And I think that one of the biggest issues, which is pretty common in the United States, is unconscious biases that people still have. We have this vision of a scientist as this crazy white guy with big hair, and not big hair, but
the Einstein look.
The Einstein look, right? And that's not what it is anymore. And so I think being exposed to different kinds of people that do science can start to clear that up. But I think that institution-wise, there has to be a lot of work to recognize that we all have biases. We think we don't, and scientists especially think they don't. They think, nope, this is the data and this is the way that it is. But they actually have done studies where they, when they give women a test, like let's say it's the SAT, if you have to check the box that says male or female at the top before you take the test, you perform worse on the math section than if you had to check it after you took the test. If you are already telling yourself, I'm in this group that is supposedly not good at math, and then you perform that way. And
that's
so,
interesting.
It's a self-fulfilling prophecy that this is the way you think you're supposed to be. They've also done studies where they had a group of Asian girls, and they interviewed them before they took a test, and they interviewed them about their Asian heritage, and then they took the test. And they interviewed another group about their roommates, and they took the test. And then they interviewed them about their phone company, and they took the test. And so depending on what they asked them beforehand, it influenced how they did. And so the women who were asked about their Asian heritage, which is supposedly, good at math, they did the best. And the ones who were asked about their phone companies did in the middle. And the ones that were asked about their female roommates, all of a sudden they were, oh, we're a woman, we don't do well at math. So it's a lot about the biases that you have to recognize.
Not to mention self-imposed biases, but the ones of teachers where they have lower expectations of certain groups and so forth.
Yeah, it's true.
So, what kind of methods did you use? Say, for example, when you were studying and you ran into an obstacle, obviously going into genetics at the PhD level, you've obviously run into some roadblocks from time to time. And, some of the preliminary courses in math and so on, you might have had some of the same experiences. And typically a student in that situation, if they find it really tough, they might give up. And in that case, we lose potentially a great scientist who didn't go past that obstacle. How did you get past those obstacles? What was your method and technique?
I guess I kept the long view, which now I'm realizing I don't always do today. But I knew what I wanted, and I wanted to be a research scientist that studied genetics and did gene therapy to try to cure diseases. And so that meant, I had the path laid out in front of me. So I had to do this, I had to get this grade at this stage, and then that grade at that stage. And I had to then get a research fellowship and on and on. So I had to think, okay, I have to do well on this test, or I have to study harder to be able to achieve that. And look past the smaller obstacles to realize that he's in goal at the end, which I think is actually the key to being a really good scientist, is having perspective. You get a result, it's not what you thought, but you say, well, what can we learn from it? And you try to keep perspective, and that's really a great thing for life, too, is to not get knocked down by those smaller obstacles. And if you can't do that, you're not going to make it in science. You get knocked down constantly. Of course, you do that in a lot of careers.
So the advice to a promising student is expect it, go deal with it.
And realize that everybody else has done that. You hear about successes,
sure,
so you don't think that's the case, but it's true. Everybody gets knocked down. The only shot you miss is the one you don't take, right?
That's right.
So you have to keep trying.
Nothing wrong with failure.
Right.
It's really the precursor.
Yeah, you have to have the entrepreneurial spirit.
That's
just
right.
saying that you might fail.
Right, exactly. So, thinking more broadly, what major scientific breakthroughs do you anticipate? You've obviously, as a writer, you've begun to deal with a lot of subjects in science. So do you see any breakthroughs that you anticipate, maybe some of the interviews you've done in your research, for your articles that you would anticipate over the next, say, 5, 10, 15 years?
That's an interesting question. Personally, I'm a big fan of immunotherapies for cancer. So I think the idea of using your own immune response, that would be what you would use to fight off colds or viruses, to actually fight off cancer, is a great...
The Duke polio.
Right, the Duke polio. Yeah, and there was actually an article in the New Yorker that came out like today or yesterday about it, about immunotherapies, and it was one of those things that people kept working on, and they thought it was overhyped. But I think there's a lot of value to it. And actually, I mean, as a geneticist, I'm a big fan of the Human Genome Project and its application to treatments for any kind of diseases. So I think that gene therapy is a huge area that has seen a lot of progress. They've cured some root causes of hereditary blindness. They've got some great progress for some other diseases like muscular dystrophy and rare diseases. Not the idea that you would be just changing my eye color to blue, but actually things that there's no other hope for.
Okay, so given that the genome was first deciphered, 2002 or 3, somewhere in there, and we are now 15 years down the road, do you think we are where you thought we would be after this many years after the genome?
Yeah, everybody said, where are the cures? Where are the cures?
Right,
yeah,
right.
No, that's a great question. I mean, I guess having done this, and having done the research, I'm not the least bit surprised we are where we are. I mean, I actually did work on gene therapy for my PhD, and I cured a blood disease in cells, and I knew that it would be decades before that it would ever make it to a patient. And it's kind of a shame I didn't stick with it, but I just knew that I didn't have it in me to do that.
All those years.
Yeah, all those years. And
FDA.
Actually, since then, there's this new discovery, this CRISPR technology, which is like
I was
these...
going to ask you about CRISPR.
Yeah, which are like these scissors that can go in and cut up your DNA and then replace it with, the right thing.
Gene editing.
Gene editing,
yeah.
And because of that, probably what I would have kept working on would be obsolete, because this is better. It's a lot better, and so I
Maybe
think,
you can explain that for the promising student.
Okay. So essentially, what it was there's a way for bacteria to fight off viral infections. So viruses don't just infect us; they infect lots of lower organisms and bacteria. Phage.
Yeah.
And so so bacteria had evolved this way of kind of recognizing viruses when they would come in and chopping them up as a way of defending themselves. And several years ago, researchers discovered this, and they just thought it was kind of cool, but they ended up testing it, and they figured out that they could just kind of hijack this system and apply it in mice and other organisms, and then eventually human embryos even, to try to, it's pretty much, there's a cut and paste. It goes in, cuts it, replaces it with something else. And so it's an amazing technology, because previously there are other kind of things that are similar that people have figured out, but it was really hard to do. And this is one of those things that's like off the shelf, that people are able, just like ramen noodles almost, you can just, anybody in the lab can do it, which is kind of scary.
I was going to ask you about that.
Because, there are actually conventions of scientists who are discussing whether or not you should be able to do this.
The Ancillomar conference concept.
Yes.
So what would you say are the ethical dilemmas, not just in CRISPR, but in general in genomics? Have you thought about some of those ethical dilemmas and what we might have to do to solve them?
I think, nobody wants designer babies. That's always been a huge concern. But I still think, being in it, there are leaps, but then every time you take a big leap, there's several steps back. So I feel like we're so far away from it that it's less of a concern for me. But I think that's still the fact that there was the Chinese study where they actually did testing on human embryos using CRISPR, and they...
Did they have success?
They didn't have success.
Oh, okay.
And so they reported that they didn't have success, but the fact they had attempted it was a huge alarm.
Right.
So I think that there needs to be more discussion I don't think that the Bush administration, the way they had a moratorium on stem cells, was really the way to go. I think there just need to be more open access discussion over what's happening. Yeah, because it has great potential.
Sure, for positive.
For positive.
But
yes.
that is also one of the characteristics of any great invention or development or achievement, is that there's a double-edged sword. There's a way it can be used in a negative way as well as, we hope, in a positive way. So that's why the ethical questions become paramount in terms
Right.
of having those all sorted out even before you do it. Because in a way, the idea that you said where they had a moratorium, that's not really going to stop any research. It's going to happen. It's
Right.
it's kind of inevitable.
Yeah, it all just is going to happen overseas.
Yeah,
I mean, that's what
somewhere
happened, yeah.
someone is going to do it. So you might as well try to lay out a platform or a kind of an immune system, so
Yeah.
that you can protect yourself against some unintended consequences. Yeah, exactly. So now, what would you say are not so much achievements like we asked earlier, but what are some major problems in science that you see need solving, and you have any thoughts on how they might be solved?
Well, I think one of the biggest issues is regulatory science, which sounds dreadfully boring, and it kind of is, but it's how the government or the FDA decide whether a drug is safe, and whether a certain device or approach is appropriate for use in humans. And they're doing it the same way they did it decades ago. They've never looked at the process and tried to figure out a way to make it quicker. And so it's the whole, you asked me about the Human Genome Project. Part of the reason there aren't cures out there is because you start to come up with these ways to apply them, and you have to go through phase 1, phase 2, phase 3 trials, and we don't even know if something's going to work or not until 17 years later. That's the average of how long it takes for something that's discovered in the laboratory to make it out into the clinic. And even then, it's a very minor percentage. So I think that coming up with better ways of speeding up that process is really the best thing that can be done.
So you would say that the FDA, for example, is too strict, too slow, or are they too willing to approve something that has risk factors?
Yeah, I think it's a bit of bureaucracy, and then also I'm not sure that they've really thought of innovative ways to assess. Like, maybe instead of it doing a clinical trial, maybe they need to come up with new modeling systems that model on a computer before you even get to that stage, or new preclinical models, which a preclinical model would be like mice or primates, looking in those. Well, a lot of times that doesn't translate, so maybe there's a way that you could create a little organ on a chip, that's a heart, and then you can test the drug to see if it'll actually improve angiogenesis before you even get to that stage, because a lot of money gets wasted. So it's not just the FDA, it's the whole process, but you could never make that jump because they think that you have to do phase 1, phase 2, phase 3. There's no better way.
There's no shortcut.
There's no shortcut.
And the whole idea of like computer modeling sounds very plausible, considering if you go into astrophysics, they can model the beginning of the universe.
Right, yeah.
And they do it very accurately, apparently.
Yeah.
So why couldn't they model systems in the human body?
Right, exactly.
So, what would you say at this point is the greatest achievement that you've made so far in your work?
That I've made?
Yeah. This is early on, so you'll get even greater ones later. So.
Oh gosh, I don't know. I had an article come out last week in Scientific American that I was really excited about because I came up with the idea and I convinced the editor to give it to me, and it was on the placenta and Zika virus and how pretty much that misunderstood organ that only shows up, for 9 months and then goes away and then comes back again if you get pregnant again, is the one thing that's standing in the way of the Zika virus circulating through a mother's bloodstream and the health of her unborn child. And so there are all these devastating birth defects out there, and it seems like everybody's talking about Zika, but they're not talking about this organ that is a barrier, and it normally prevents most infections, but it's not preventing Zika from getting to babies. And there's not much funding for it. And so I had a chance to talk to several scientists that are working on it, and I'm hoping that, if my article came out and people read it, then maybe
it can help prevent birth defects.
Right. Yeah. I'm hoping. Yeah. I mean, it came out the day that the Senate was voting on Zika funding, and so I thought, well, maybe a couple of them read it. Who knows?
Yeah, right,
you know.
Right. And they might approve the funding, like they're not seeming to be able to do at this point.
Right.
At the level in which the CDC has requested.
Yes.
Right. So yeah, I would definitely look for that article in Scientific American. That's congratulations.
Oh, thank you.
That's a very premier publication. Yeah. So, okay, so you've come to this conference where you have some eclectic practitioners of caloric restriction, and obviously you studied a lot of other things, being a geneticist. How has what you have learned informed your lifestyle and your health practices, for example?
Well, I think I'm going to eat more vegetables. I thought I was being pretty healthy, but I didn't really. I mean, there are people there who eat, the CR Society, who eat 9 to 10 servings of fruits and vegetables a day, and that's a lot more than I ate. I thought I was eating a lot. But I think I do a pretty good job of mindful eating, but I think that that's a good thing to try to continue to do and to encourage other people to do. And the whole idea of cancer as a metabolic disease is very interesting to me too. So I think that I'm interested in learning more about that. And I've been amazed by everybody's self-discipline and the strategies they use, which I think could apply to other parts of your life too. I mean, it's not just food; it could be in anything.
That's right. So, last couple of questions. Could you explain your PhD thesis for a layman?
Oh my goodness, it's been so long. Gosh. So,
just generally.
Yeah,
I mean,
generally.
I'm not the review committee.
Yes. So it was on a disease called beta thalassemia, which is a Mediterranean illness. So it's kind of like how sickle cell anemia, the blood cells are sickled, and so they don't carry oxygen the way they're supposed to. But in beta thalassemia, there's subunits of hemoglobin, which carries the oxygen through your blood, and there's 2 alphas and 2 betas, and so beta thalassemia means you don't have the betas. So you're very anemic, very sick, and there's not many treatments out there for patients. And so I worked with a couple grouped populations in Italy and Thailand that had a certain genetic variant that caused them to have the disease, and figured out a way to kind of block the variant so that they were able to produce the proper amount of hemoglobin they needed to carry oxygen through their blood. And so I actually didn't do it in the patients, but I got blood from Italy and Thailand and then treated them with this new kind of therapy. And I actually did have patients calling afterwards asking when they could get it, which it was a long ways away from it. But we did it in cells, in test tubes and cells and in mice. Yeah.
So that's a great achievement. That's one of your great achievements.
I guess so. I don't know. It's not there yet.
Well,
if I ever saw it in a patient, that would be pretty exciting. Yeah.
Right. Well, how many PhDs in genetics in your gender in America?
Not that many. Yeah.
There you have it. That's
Yes.
another achievement. So, okay, how would you describe a typical working day in your profession, like from the time you wake up to the time you go to bed?
I spend a lot of time staring at the screen, just staring at it, hoping that words will flow. And then after a certain amount of time, it starts to flow, but it takes a while. So yeah, I have 2 kids, so the day starts with getting them to school and getting back, and I spend the morning trying to read whatever's online to try to keep up with the news. And then I normally have at least 1 interview a day based on whatever stories I'm working on at the time.
Phone interview?
Phone interviews normally. I do some in person.
How do you get your subjects to be interviewees?
Well, normally I'm helping to promote what they're doing. So I they're almost always very receptive. Sometimes I have to be very flexible with what time I talk to them or how much time I take of them. But yeah, and sometimes it's tricky because scientists aren't always great at communicating what they do. But I can only get out enough.
So how do you consolidate that information that they present over the phone? You record it, or you write it down, notes?
I normally record if I can,
Yeah.
and then I try to take notes at the same time.
Right.
And then if it's really, really complicated, I'll transcribe it so that I have everything there before I start writing.
Right.
Um,
So you transcribe it yourself, or you have a machine
Sometimes
that
I
does
transcribe it, or I use a service that does it for me.
Is it
Yeah.
what service is that?
Rev,
RE.
REV, yes.
Okay,
It's
.com.
online, yep.
I need that.
Yes.
Yeah, right. Okay.
Yeah, it's a reasonable service.
Okay.
I've looked around.
Rev, because I've got material that I need to
Yes.
get transcribed. Okay, the last question is, what is your definition of success?
What is my definition of success? That's a great question. Right now, succeeding in life to me means constantly improving and getting better at what I'm doing. I mean, I think I have some other things like helping other people get better at what they're doing. I really want to write my book and have that be really well read. So
On
just-
hunger.
On
Yeah,
hunger,
yeah,
yes.
we gotta.
Yeah.
Wait, maybe tell me a little bit about that before we close the interview.
Yeah. Well, I just think that it's an interesting concept that people don't necessarily know a lot about. So I think that's what I think motivates me the most is writing about getting people interested in science that might not be interested in science. I mean, my husband actually read my Scientific American article because he was like, "That's pretty cool, Zika and the placenta." I mean, he's an accountant. He wouldn't normally read that kind of stuff.
Right.
So I think that's kind of part of what motivates me is trying to get other people to appreciate what we appreciate. You know?
So maybe briefly you can describe what you learned at this conference that can contribute to your report on hunger.
I don't think I want to get too much into it.
Okay,
Yeah.
till you write it. Right,
Yeah,
right.
yeah.
That's
I'm still processing. I actually have a notebook right here. I was gonna just like write out a bunch of stuff
Right,
to try
right.
to figure it out. So
Right.
I really enjoyed the conference. I think that I'm a bit of an introvert, so it takes me a little bit to process and figure out what I'm gonna do with all the things that I absorb.
Right.
Yeah.
That's right. Well, fortunately, with the PhD, you understood all of the things that they presented, right? All of the graphs and all
Well,
of the
clearly you
tables.
did too. So yeah.
Not quite. I must tell you. Thank you very much. This
Thank
has been
you.
very
That was
informative.
fun,
Yeah,
yes.
that's been very. I think it would be quite inspirational to any promising student.
Oh well,
Yeah,
thank you.
Right, because you have some clear and how should we say, great insights.